Hello everyone. Today in this video I am discussing about DSB AM transmitter. In DSB AM transmitter, amplitude modulation is a type of modulation in which amplitude of the carrier wave is varied in proportion to the message signal. Such as message signals are such as audio signal. Okay. In this experiment, our main objective is to study about amplitude modulation. To perform this experiment, we require different apparatus, and these are Scientech kit, which is designed for amplitude modulation or DSB EM modulation, and DSO connecting wires. In double sideband suppressed carrier transmission, in which frequency produced by amplitude modulation is symmetrical above and below the carrier frequency, and the carrier level is reduced to lowest level. Actually, in AM modulation, DSB SC modulation is used to perform AM modulation. In DSB-SC, both the sidebands are present by suppressing the carrier at the output side. This is the circuit diagram of AM transmitter. Here we need one audio input to generate the message signal or information which we need to transmit. To transmit this, we required one carrier signal. From carrier generator, this carrier signal is generated, and then both the audio input and carrier signal pass through a balance modulator. Actually, balance modulator only pass the sideband by suppressing the carrier of the signal. Okay, and then we just amplify the output of the balance modulator and then transmit the signal. In balance, after balance modulator or using balance modulator, we transmit the signal using three different modulation technique. First, we just use mid modulation technique, actually which is less than 100% modulation. So in this case, you see everything is mentioned. BC means voltage or amplitude of the carrier signal greater than message signal, and the output waveform whatever we got at the output side of balance modulator is looks like this double sideband waveform or envelope shape waveform. Okay, so this one is your first mid modulation technique. From here we just measure the signal voltage, means Bmax, Bmin as well as Bm, Bc. Okay, and frequency of the carrier whatever we use, and frequency of the input signal or message signal, all the things whatever we need. Okay, and then we use another modulation technique which is full modulation equal to 100%. In this case, your BC equal to Bm and your modulation index value is 1. M didn't define the modulation index value. Okay, and last one is your over modulation, which is greater than 100%. In this case, your VC or carrier signal voltage is less than Bm and modulation index should be greater than 1. In the observation table, you note this thing. First, input signal voltage as well as frequency, and then carrier signal voltage as well as frequency, and draw the output waveform, the input as well as balance modulated output, and then find the modulation index. Modulation index is defined as your Vm by Bc into 100. Okay, now we are going to perform the experiment using the kit. So student, before starting the experiment, you see this is your DSB and SSB amplitude modulation kit where you just perform the experiment. Okay, you see this is your audio oscillator from where we just apply the audio signal or message signal, and then it pass through this line and goes to balance modulator from where we apply one carrier. You see this one is your carrier generator. Its frequency is fixed 1 megahertz. Here both the carrier and audio input is applied, and by varying this pot or knob we fix three different conditions, and these are mid modulation, full modulation and over modulation technique. By using this technique we just transmit the AM signal. So from here we note all the data. Using this waveform we note all the data for finding modulation index and check whether this condition is satisfied or not. So you see, I will roughly take all the data and then I will show how to measure. First case we measure the mean modulation. In this case your BC is greater than BM. Okay, first find Bmax, Bmin, and your Bmax is BC plus BM is Bmax. Actually, to measure BM and BC, we use this balance modulator. In this balance modulator, both the audio input and carrier input are attenuated. So, using this balance modulator, we measure BC and BM. Okay, not we calculate the BM from here. Whatever the condition we satisfy or set here, from the output of the balance modulator signal, whatever we got in the DUSO, we just measure the BC and BM. So similarly, we see BC plus BM is Bmax, and then we measure the BC and then subtract this and we got the BM. So similar way we measure the data for full modulation, Bmax, Bmin, and then BC, BM, and then find the data for over modulation. So in this way we measure all the data for three different conditions and find the modulation index using BM and BC. Okay, so now start the experiment. You see here the audio input is given, from where we just apply the audio or message signal. Here message signal generated and it passes through this line and goes to your balance modulator, and the carrier is generated from this carrier's generator section, and its frequency is fixed 1 megahertz. Both the audio input and carrier applied to this balance modulator, and by varying this pot we fix three different conditions. You see, when we vary the pot or potentiometer pot knob of balance modulator, we will see the different waveform or different modulation technique, find the three different modulation technique. So first we set the mid modulation technique and then go for the next one. Okay, you see this is your mid modulation condition. So we measure the data, all the thing manually. So press over cursor and then first measure Bmix, first find the Bmix, and then this is your Bmix and then Bmin. Okay, this is your BB. Now to measure the BM and BC, we just off this input side signal, and here only present the BC. Okay, so we subtract, you see, of this. Here only balance modulator output, which is BC, is present in the signal. Okay, so from here we measure the first VC. So this is your VC. Which is 584, and you subtract this thing from Bmax, and then we, whatever the value of the amplitude we got, it is your Bm. You see here, whatever I will show you in the video. You see Bmax is in this one, and then measure BC, and whatever we subtract this value from this, and we got the Bm. So this is your first condition, and now we set the second condition. In this way you have to measure all the modulation technique values. So this is your next condition, which is full modulation. Similar way, we first measure the Bmax value and then Bmin. Here Bmin is almost 0, you see. You see its value is very negligible, 16 millivolt. So similarly, now we just remove this connection to measure to measure BC from balance modulator. Just off this connection, whatever the value is given here, it is your VC. So and this is your VC, and then subtract this thing from this value, and similarly we got this measurement or reading for a full modulation. Okay, so you see Bmax and whatever VC we got from here, just subtract this and see this condition is satisfied. Now we need to measure the frequency as well. So to measure frequency, just change this to step time. So you see the carrier frequency, whatever the present in the balance modulator output is in only carrier is present, its value is 1 megahertz. You see, and here you see only 1 megahertz one, and you see now no signal goes to your balance modulator, only carrier is present there. So in this way we measure the carrier signal frequency also. Now see the frequency of BM, just connect this probe over there. Okay, you see okay. So you carry BM or Actually audio oscillator frequency is this is. So in this way we manually measure all the things for three different condition. Okay, so now lastly we check the last condition for over modulation. So this is your last condition, which is over modulation. So here select the cursor. So in the similar way we have to measure the Bmax and Bmin, all the things. Okay, this is your Bmax, and similar way we just disconnect this panel, and whatever the output over there, only your BC is present. So measure the BC from here and subtract this BC from Bmax, and we got the BM. So similarly you have to measure all the things for three different condition: mid modulation, full modulation, and over modulation, and find or transmit the signal, okay, using three different techniques. And the output side, we just amplify the output of the output, whatever DSB output we got balance modulator, we just amplify the output using output amplifier, and then we transmit the signal through antenna or socket, whatever you need. Okay, so you see here, this is the reading for over modulation. Here you see Bmax is given, BM, Bmin also there, and then find the BC and BM, and frequency is the same. Okay, in this way we generate the AM signal and transmit the signal. Okay, thank you.